Hi, hello. My name is Francis Nweke. I'm a PhD student at Kennesaw State University, and I'm pursuing my PhD in computer science. And my advisor is Dr. Hafiz Khan. And this project is a recent project we worked on, and I'll be presenting it here. And just give you a walkthrough here, and hopefully I'll also be showcasing it at C Day or on C Day. Um, the title of my paper or the title of my presentation is Explainable Multilabel Classification Framework for Behavioral Health based on domain concepts. So what you need to get out from the title is that we basically apply machine learning to behavioral health analysis, and the question might be why behavioral health. Behavioral health is a, quite a big topic right now, considering the fact that it does affect every single person, indirectly and directly, because you look at the data from the Substance Abuse and Mental Health uh, Administration Services. The data from 2020 suggests that above 54 million persons have behavioral health issues, or one behavioral health issue or the other. And when we say behavioral health issue, it does encompass mental health, substance abuse, addiction, and disorders and all that. So it's quite an elaborate and a very big topic to discuss. Like I said, it does affect every single person, right? So because when you think about behavioral health, you might be thinking of the very high cases, drug abuse and um, substance abuse, that's drug abuse, and the more very serious cases. But also we have to look at the very mild cases, at depression, uh, the eating disorder, and the rest. So it's an issue that needs more attention, I would say, than what is getting right now. Or yeah, we hope in the future that could get more. So basically, what we've tried to do in this work is that we've tried to apply machine learning to it, to behavioral health analysis. But if you look at behavioral health as a domain, behavioral health falls under healthcare. And with healthcare, you don't just answer the question of solving problems or like applying machine learning to it and getting results. That's great. That's always very good and welcome. But in addition to that, we have also looked at the angle of explainability. That's we want a model or a framework that is able to give us classification or classify, given an input, it should be able to classify the input into one of the determined or predefined behavioral health classes. But in addition to that, it should tell us the reason why it thinks that um, that input or that particular document or whatever it is, let's call it input, that input belongs to that particular class. So we want reasons for that. So we've applied a few techniques here to be able to answer that question in terms of how and why together, since we consider this a very sensitive domain. So there are a few research questions we answered in this work. Like we try to look at how our framework perform with like other state-of-the-art models. We also try to look at the benefit of like incorporating domain concepts. So the domain concepts are basically keywords and certain types. So we have a keyword, like giving a keyword. Keywords are just phrases. So giving a phrase or a keyword or a word or sentences, uh, we categorize them into different types called evidence types. And these evidence types are predefined by subject matter experts. So we also collaborated with subject matter experts to come up with those evidence type and the behavioral health classes. So we have a component here that is able to learn or take in those keywords and the evidence, corresponding evidence type, and learn the relationship between them to be able to help the classifier. Also, we looked at the concept of attention. Attention is a concept that already exists in transformer-based models. So we took attention weight and we try to use them to look at what the model is focusing on in terms of making classifications, then use that to generate human readable explanations. Then also, since we did a little bit of analysis with other state-of-the-art with our own proposed framework, we try to also produce the common errors, or like show the errors in terms of error analysis. We did that also. Then we have like a module called the SRE, which is basically the semantic representation encoder. So when we take all the keywords, the evidence type, and all that, we try to encode them and find relationship between them, and try to learn that, because that will be useful. So if you know a certain keyword belong to a certain type, and you get to learn that particular keyword, or certain keywords that belong to this type always goes to fall under a particular behavioral health um, behavioral health class, that helps in terms of like providing reasons for the classification. So I've already started talking about the methodology here. So that's basically, if you look at our methodology here, we have the domain knowledge, which domain knowledge here is extracted from doing annotations by subject matter experts. So this subject matter experts, they sit and do this annotation to be able to help us come up with the data we use to train our model and perform the analysis and the experiment. So we have that, and we also have the public narrative from the police department, which thanks to them for the collaboration and providing the data. So we use that, and with the help of the subject matter expert, we're able to come up with certain keywords and also define the behavioral health classes we'll be using here. So all that was done by subject matter experts. So once we have the data, we extract the ground truth, do the annotations, and we have matching keywords and the corresponding type. Then we were able to feed it to our architecture and our design here. So we have all that here. You can see from the diagram, we have the transformer-based feature learner, which learns the feature. It also takes that from the semantic representer, or semantic representation encoder, which is the SRA, that takes that in and also is able to provide the feature embeddings, which is passed to the classifier. And the classifier is now able to make the classification in terms of classifying an input into one of those classes. And since, like I said, the transformer is able to generate annotation weight, we use those annotation weight to capture some certain keywords and extract them. And we're able to say, okay, based on the keywords, or based on keywords with certain attention score, let's say we have a threshold of 0.5, so 0.3, or whatever threshold you set to it. So based on attention score of 0.3 and above, we extract those keywords and say, okay, this keyword does have a little bit of weight in terms of helping this model, helping the classifier classify this into one of those classes. So we present some of the results here, and the comparison, like we said, the first research question we had was to do comparison between our architecture with that of this existing state of the art. And we have the accuracy, precision, recall, and F1 are some of the evaluation metric we use for that. So we have that. Then we also did class-wise performance. So in terms of like for each class, how did the model perform? How did our framework perform for each class? So like I said, we have a couple of classes here, 5 classes. So based on those, in terms of how did the model predict those classes individually, not just the whole performance of the model. So given a class, how did the model perform for that particular class? And also you use the metric of the precision, recall, and F1 there. Then we also answer the question, like the question, research question that has to do with the attention and read, and generating clear human readable explanation. We extract the, you can see there at the research question 3, visualization of the attention map and human readable explanation. So once we extract those attention weight, we're able to use the score and the threshold we have set to be able to say, okay, given so and so input or so and so document report, in this case, the police narrative reports, we have certain keywords or certain words in that document points that this keyword belongs to this class. So the example they're presented is, we are saying this document belongs to domestic and social. Why? Because we found so and so keywords, found trespass, criminality, people, and all that. Yeah, so as you go on, certain keywords will have lower attention score, which does suggest that they might not play so much role um, into helping the model make, or the framework make that classification. So the keywords with lesser with very less attention score, we pay less attention to them, pay less attention to them, right? So that's the concept of incorporating like the attention weight, then get scoring each keyword based on like how they're helping the model make the classification and all that. Then we look at the incorrect examples. That's the error analysis. We perform a few error analysis. We looked at the cases where the model failed to properly classify a document or a report into the appropriate class. So given this document, the model did predict, we said it's a multilabel classification problem. So the model did get one of the classes right, but he failed to predict the other class, which is the mental health, which is in red. So he failed to predict that correctly, and he got the domestic and social. Unfortunately, he didn't get the other one. Then we fall back to looking at the relationship between the encoder, that's the SRE, where we are kind of mapping the relationship between the keywords and the evidence type. Like I said, certain keywords are tied to the corresponding evidence type. So we can see a keyword like mental health issue belongs to situation and behavioral health, domestic disputes involved in a knife is to situation, and the other keywords and others, med and alcoholic beverage belongs to drugs. So recovering from addicts, it also belonging to drug. So certain keywords are just phrases. So that's the concept of like the domain concept. So we bring in like phrases that actually mean something in behavioral health. So we try to learn all those phrases. So we're trying to incorporate it in our SRE, which learns the presentation and relationship between these keywords and their evidence type, and be able to help the transformer learn, and also in turn help the classifier learn those relationships. So basically that's what we've done. And in terms of conclusion, so we've tried to answer the question of how do we solve behavioral health issue analysis using machine learning or deep learning. We've done the classification, but in addition to the classification, we've also tried to answer the question of why, because this is quite a very sensitive domain. You don't just want the answer of saying, okay, we're able to solve this problem, but you didn't provide the answer of like, okay, why? Why do you say this is this? We need reason for whatever we are imputing there. Yeah, thank you very much, and I hope to see you at CD. Thanks.